Alright, in this video we'll continue with the C# video tutorials, so we'll be continuing with arrays and finding the highest value in an array. Okay, so create a variable to hold the found highest value. Start with assuming the element 0 is the highest. Use a loop to step through element 1 and the rest. Each time the loop iterates, it compares an array element to the variable holding the found highest value. Excuse me. If the array element is greater than the found highest value, assign the value of that array element to the variable holding the found highest value. When the loop finished, the highest value is found. So let's do an example of that. Okay. So we have some extra stuff here from the previous videos. I'll just delete some of that stuff. So let's delete that. Okay, so let's maybe just try to do this in the code area. So let's just go private. Let's make it into a method, like a support method or something. So private void. What are we trying to do here? Highest value, highest array value or something, or get highest array val, whatever. That's fine. We could say that it takes an int array. Actually maybe not, because we don't really need that. We could do that. We could set that up, pass in the array from the constructor and the fields and all that. We'll just go with a local array here. So how can we declare? So let's pretend I'm your professor and I'm asking you how can you create a local array? So that's the question. That's the first question on the test. So that's to create a local, let's say, our int array. Actually, let's go with double since we always create int arrays. So we'll go with a double array. So how can we do that? So if we want a local array, we just declare it like just a local variable, pretty much. So a local array, let's just say. Actually, I don't want two types in the name. So double array, val array, points to, and then we'll initialize it like this. One. We'll just do some random numbers here. Something like that. Excuse me. So this is a way how to instantiate an array the easy way. You don't need to actually instantiate an object. I forgot the name for this. Anyway, so let's say int highest. Actually, technically we need doubles then. So double highest points to val array. So val array of index 0. So it's not going to be the highest value, but it'll start that. It'll start that. It'll start as that. That won't be true yet. So double highest. Let's go with highest val or something. Highest val points to val array of array index 0. Obviously, this number 1 is not the highest value in this array, right? The highest value is 9, not 1. So this statement isn't correct yet, but how can we make it correct? So we'll have a for loop here. We'll iterate through the value. So we'll say int I points to 1. So it's going to start at 1 instead of 0. Then we'll say I is less than val array dot length. Then we'll say I plus plus. And here we'll say highest val points to val array. Oh, my bad. There should be an if statement here. So if val array of array index I is greater than highest val, then we'll say that, well, then obviously what are we going to do? Then we're going to switch highest val to point to the new element that's higher than it, right? Why is there two spaces there? Okay, so in that case we'll say highest points to, highest val points to val array of array index I. So once again, what's happening here? So if val array, on iteration 0, or sorry, iteration 1, the first iteration, we're starting at 1, not 0. Because highest val starts to point at val array of array index 0, therefore highest val is already being checked. Therefore we can skip the first element, so that's why. Okay, so if val array of array index I, which is starting at 1, is greater than highest val. So if val array at array index I, which is 1, in this case it's going to be the value 3, is greater than the highest val, which points to val array of array index 0. So is 3 greater than 1? It is. In that case, highest val now points to val array of array index I, which is 3. So we swapped it. That's how you check. Excuse me. That's the answer. That's the way how to do it. Okay. So on the flip side, we can do private void get highest array val. Now we can do get lowest array val. So obviously I think we just flipped the sign here actually. So we have an array lowest val. Well, let's just write it out for practice. Anyway, so we'll just go here. So we'll go private void get lowest. What did I call this? Get lowest array val. Right, easy. So then here we'll have parentheses. Then here int array val array. We could have another local val array points to, well, we could really just do it backwards, but that's fine. You could have a random kind of number of numbers. Either way, it doesn't really matter because it has to check each element one by one anyways. There's more efficient sorting algorithms where, for example, it won't check every index, it'll try to check half of them, or even as only one or something. It'll try to reduce that's in data structures, but that you want to reduce the CPU time and the memory usage. So you want to reduce that's how you learn how to make programs faster. It's a good, data structures is good to know. It has a lot of concepts about code that's really powerful. That'll take you a long way. So data structures is in every programming, should be in every computer science curriculum, at least in the Canadian curriculums. I haven't looked at too many Canadian curriculums, so I know usually in the ones that I've seen, you will have a data structures class. You should. Usually they do it in C or Java. I did mine in Java. Some people have it in C. Some people have it in C#, maybe 2 or C. Not C. Actually, some people, I don't know if a lot of people do it in C#. Usually more so C++. But it should be one of those. I think they even do them in Python too. But it's going to be in one of those core languages. Okay, so anyways, so we have int array val array points to some values here. And we'll say int lowest val points to val array. No, int lowest, actually, yeah, val array of array index 0. Sorry, let me just do one thing quickly here. Okay, sorry. Okay, so we have int lowest points to numbers of array index 0. Then we'll have here for int I points to 1. I is less than val array dot length I plus plus. We'll say if val array of array index I is less than lowest val. Then we'll say lowest val points to val array of array index I. Same thing, so we're going to flip it. What's happening here? So we're saying, okay, well, it's the same thing, right, that we just did, except we're flipping it. So in lowest val points the val array of array index 0, which is 9. Lowest val points to the value 9 at this time. Excuse me, so remember, 9 is index 0, 1, 2, 3, 4. This array has 5 elements, index 0 to 4. So lowest val points to 9, the value, it's an int in this case, not a double. So then the iteration is going to start at 0 in the at 1 in the loop, since we already went over the first element. So then here it's going to check on iteration 1 if val array of array index 1, which is 7, is less than lowest val. If that case is true, then this statement gets executed. If this statement is false, this block gets skipped and it loops back up to the top. So in this case, this statement is true because 7 is less than 9. In this case, now lowest val points to 7. So it's changed, lowest val changed from 9 to 7. It switched. Alright. So we can continue this to advanced algorithms for sorting and searching. So we're almost done with arrays here for the notes. Then we'll have a bunch of code examples to do. I know we've had some code examples here, more than normal, but that's okay. It's better than just like theories and stuff. So there's a selection sort that's like a data structure sort as well. The selection sort works by locating the smallest value and moving it to element 0. Then find the second smallest and move it to element 1. Continue the process until all the elements have been placed in their proper order. So this algorithm requires swapping for array elements, which can be done by the following. They use the ref keyword here. Not really sure why. Okay, so let's have a method here called swap. Private void swap takes parameter ref int a comma ref int b. Oops. You could say int temp points to a points to b, then b points to temp. So in order to swap something, you can't just do it with 2 lines. You need, because it's just going to point to itself, you need a third variable. So this is a common coding question even on interviews. I've seen these on Google interviews, like on YouTube, and like even like those companies like Amazon and stuff. It's a good concept to test someone on. It shows at least they have understanding of variables and data, at least a little bit of data stuff. parameters and all that. Yeah, so that's it. Int temp points to the first variable. Then we say int temp points to A. So int temp, so temp's going to point to A. Now A is going to point to B. And then B is going to point back to temp. So this is something you could even get tested on. It's definitely a university test question. I've seen this several times. In every language almost. C, Java, now C#. Python maybe. I think even Python has this. I've seen this example in Python too. Android, not so much. It's not so much with data structures. It's not so much focused on data structures. XML, obviously, not really. You don't really focus with variables on XML. It's mostly like visual stuff. But that's how you do it, and it's a good thing to know. If let's say I erased all this, I don't know why you need a ref keyword. Why they chose to use the ref keyword here. You don't need this can be done without the ref keyword. I know that for a fact. Perhaps you can change the value or something. Anyways, that's swap. So the swap you have to use. So we said, what were we saying? This was selection sort. Selection sort. Okay, so in order to use a selection sort algorithm, you need to have a swap method. So we'll call this selection sort. Private void selection sort. Selection sort takes. I'm not sure if it takes any parameters. This is like a half example, so I'm going to try to elaborate here. Okay, so we have, for example, int min index, int min value, for int, why do they use start scan? Excuse me, I'm going to swap out this word for I. So int I points to 0, I is less than. I array, why is it called I array? I think because it's an int array. Let's just go with I array. Dot length. What is it, I array? Is that a built-in word? Oh, you know what, we don't even have an array, so it's like, well, what the hell, where's the array? So let's go with int array, I array points to some values. Actually, let's try to do some. Some random values. Alright. So int array I array points to some random values. So for int I points to 0, I is less than I array dot length I plus plus. So we're going to loop through the values, which we've now done several times. This is going to be a nested for loop. So for, let me just make sure this is correct. For I points to 0, I is less than. For I points to 0, I is less than I array dot length minus 1. I messed this up. There's a trick here. For I points to 0, I is less than I array dot length minus 1, I plus plus. make sure you have that -1. Then we'll say min index points to starts. I know this is like the hardest stuff that we've done so far. Whoops. But it's really good to know, good practice and stuff. So here we'll say min value points to I array. Anything data structures will be a little bit tricky. So min index points to I, min value points to I array. That seems wrong. You know what? What is I array? I arrays. You know what? I think something's wrong with this example because I want to show you guys this full example, but I don't have the full example. Alright, let me check let me check the actual book and see. These are my professor's notes from my class. Okay, so let me just open that up here, one sec. It's a massive book, so I'll have to get to the right page as well. Apologize for that. So let me just find this, see if I can find this example somewhere. Okay, here we go. This is 7.6, okay. 7.2, 7.3, 4, 5. There's a lot of examples in this. We're gonna love this. Lots of hard examples in here too. Well, not terribly hard, but you know, more challenging than normal that we've been doing so far in the series. Okay, so the selection sort algorithm, that's what we were doing here. Where's the actual algorithm? Okay, there we go. Here we go. Okay, private void selection sort. You know what? Let's just do it. We're going to be doing this twice, I believe. That's okay. Doesn't really matter. So private void selection sort. So this is going to take an int array as a parameter. What else we have here? We don't need anything else here. Then we have an int min index. Int min index and a min value. Let's just do it the way they did it. They decided to put it on two different lines, so int min index and int min value. Then oh, it takes a parameter I array. Okay, that's perhaps what this code was missing. So int array I array, we can comment this out. It takes a parameter int array I array. Then for I points to 0, let's just, okay, well, I'm changing some of the words that they have here. So for I points to 0, I is less than I array dot length -1, I plus plus, there we go. Then here, mint in, so then we're opening a for loop, square brackets, or sorry, curly brackets, so min index points to I, min value points to I array of array index I. I don't want to mess these up. Whoops, sorry. Just hit the mic by accident. Apologize. I have one of those mics with the foam coming up in front of my mouth, so sometimes my hand hits it when I'm juggling through these notes. Apologize. Let me actually redo this here, because I don't want to make a mistake. I'm going to use the exact same words that they have here. So for int start scan, that's what they called it in this algorithm here. So selection sort, I think I've seen something similar in other languages. They usually call it start scan for some reason. So for int start scan points to 0, start scan points to I array dot length -1, and then I plus plus. Oh, sorry, start scan plus plus. Then we say here min index points to start scan, min value points to I array of array index start scan. Then we nest a for loop here for index points to start scan. Whoops. Index points to. Is this going to be another start scan? I think so. No, actually, it's going to be this. I think it's going to be the same start scan. So be careful with that, by the way. It's always good to debug these. I think we will though when we do these later on again. We're going to do the same code later on. Don't worry. So for int index points to start scan +1 index is less than I array dot length. My bad. Forgot to initialize index here. So for int index points to start scan +1 in this case, rather than -1 in the initial nest of the for loop. So for int index points to start scan +1, then index is less than I array dot length. Then we'll say index plus plus. Now in the nested for loop, then we'll say if I array of array index is less than min value. Then min value points to I array of array index min index points to index. Like outside the nest, then in the inner nest. So within the outer for loop, we say swap ref I array of array index min index, comma ref I array of array index start scan. And that's it. I know it's tricky. We'll do this in the debug. You know what? We'll do this in the debugger. Don't worry about that. But that's how it works. We'll do the full everything in the debugger later on. We'll just get a taste of that. Okay. So the binary search algorithm. A clever algorithm that is much more efficient. And the sequential search, here is the pseudo. Okay, we'll skip the pseudo code. Sample code. You could do a little bit of this. You know what? Let's skip it. We'll talk about it later on. Let me just see what the notes have here. The book has. Binary search. there's a full binary search, so we're going to be doing that. We're getting a little bit of a taste of data structures here, so we'll be doing the binary search after, don't worry. So we're just going to take a break now, because we're getting to half an hour. We're already at half an hour. Wow, okay. Data structures take, I know it's not like the Java data structures where I have videos that are like over 10 hours, even counting, I think. About 10 hours per data structure. Which is crazy, I know. That's long, right? Those are like, that's like, I've seen YouTube videos. Did I see an 80-hour video on just like a whole section of coding, like learn Java in 80 hours or something? But imagine if I had a video on trees that was like 20 hours, can you imagine? Or even, yeah, 20 to 30 hours. I'm considering doing one of those actually. I'm gonna get everything in order and just maybe to try to get some more, like, cause you know when you have a video separated into like 20 parts, not everyone watches it. They'll watch a few parts and they'll either just figure it out by then, or they'll just decide they learned enough. So they don't get to see everything. So I'm thinking about maybe taking those data structure videos, for example, linked lists, and just do a massive linked. I think the biggest one I have is trees. That goes to like 20 plus hours. So I'm thinking about doing a Java trees, just one massive thing. If I can get all the parts for it and make sure everything's in order properly, I'll probably do that in the future. The thing is, I deleted those videos from my computer, so I'll have to somehow download it for myself. Hopefully I can get a 180p quality or whatever, because I have like a older computer, so only gets 180p. As long as it's 180p and the quality's still fine, HD at least, then I'll be able to do that, and maybe it'll help grow the channel a bit more. Perhaps I'll do the same thing later on for like Python lists. I'll do like a 10-hour, actually I don't think I spent 10 hours, maybe like 8 hours, 6 to 8 hours on Python lists. We'll do a massive video on that. Yeah, so I'll probably do that later on. If for my videos that are separated into parts, I'll try to make them into one video. Hopefully I can. But yeah, so in the next video we'll be going over 2D arrays. So even with these array nodes, we're getting into 3-4 hours now, I think, just for notes. So imagine with the labs and everything. If I was to do one massive video on that, it could be 15 to 20 hours just on arrays. So it's possible that that could happen. Maybe I'll do a C# arrays video on my channel. Just C# arrays, that's like 20 hours with labs, notes, everything. Maybe I might do that in the future. So anyways, thanks for watching, guys. If you guys liked the video, you can like and subscribe to support the channel for more programming and investing tutorials. In the next video, we'll be going over 2D arrays, and then I think jagged arrays. So thanks for watching. Hopefully I'll see you guys there. Take care.